Ooh, I'm really being tested here. You can only talk 5 minutes, so I'm going to have to talk a little faster. I've had to do this one a few times. All right, guys. So we're adding and subtracting mixed numbers today, as promised. So we're going to start with step 1, which is convert these mixed numbers to improper fractions. That's always the first step of adding and subtracting mixed numbers. To do that, we know that we're going to multiply the denominator by the whole number and then add the numerator. So we've got 5 times 4 plus 2. The denominator is going to stay the same. Adding and subtracting, we talk about that a lot. It's always going to stay the same no matter what we're doing here. So 2 and 4/10 is going to look like 10 times 2 plus 4. And remember, this is all building. So if you've missed some lessons, you've really got to go back and watch some of these lessons from the lesson library, because adding and subtracting really builds with a lot of steps that you are really going to need. All right, so let's get our new fractions as improper. So we have 5 times 4 plus 2. 5 times 4 is 20, plus 2 more is 22. We have 22 fifths. Here we have 10 times 2 plus 4. 10 times 2 is 20, plus 4 more is 24, so 24 tenths. So I'm going to rewrite this down here so that we can do a little work with it. Let me get some boxes going. All right, so we have 22 fifths plus 24 tenths. Now, we know from former lessons that you cannot add and subtract fractions that do not have the same denominator. We call those common denominators. So the very first step that we're always going to use or do when we're adding and subtracting is use our strategy to find or make an equivalent fraction. For the sake of time, I'm not going to make a list, but if you go back to LCM in the lesson library, that will help you with making the equivalent fraction. So I know that 5 is a multiple of 10, so we can use 10 as our denominator. Anytime the denominator, the equivalent fraction that we're making is already the same denominator, then I can just move it over because it's like saying times 1. Up here, I have to decide 5 times what is going to give me 10. 5 times 2 would make 10, so that means 22 times 2 will give me my equivalent numerator. So 22 times 2, I'm just doing doubles, so I'm just going to double those numbers that I have. So it's 44. Now I have my new fraction setup, still equivalent, but new setup with the common denominator. I know that the rule is the denominator always stays the same in adding and subtracting. So I'm just going to go ahead and bring my 10 down so I don't forget that step. Now I can go ahead and add my numerators, which is 44 plus 24, to get the sum of my numerator. So 44 plus 24, put my plus sign here, 4 plus 4 is 8, 4 plus 2 is 6. So my numerator is 68. The next step, let me put another box here, I'm going to convert this to now a proper fraction, or the way we like to see it. So I'm going to use my strategy for converting improper fractions to mixed numbers, because I know that the bigger number's on top. It's not the way I'm used to seeing it. So that means that there's more than one whole. So I'm going to use the mixed number strategy here. So how many groups of 10 can I make with 68? 10, 20, 30, 40, 50, 60. I know I can make at least 6 groups. So I'm going to subtract, and I'm going to have a remainder here. When we're using this strategy, our remainder becomes our numerator, and our denominator again stays the same. So we have 6 and 8 tenths. My last step here is going to be to simplify. The strategy that we've been using, 5th grade prefers, is to look at my fraction and see if I can divide both numerator and denominator by 2, 3, 5, or 7. This doesn't always work, but in 5th grade, our numbers are low enough that if you choose that strategy, you'll be okay. So we have 6 and 8 tenths. I'm going to look at these numbers here, 2, 3, 5, and 7, and ask myself, can I divide the fraction, not the mixed number, the fraction by 2? We'll start there. Yes, I can divide 8 by 2. So 8 divided by 2 is